Okay, so I'm Thomas. I work at UStudio. UStudio is a company that we've got two sort of pieces to what we sell. We've got a enterprise video media management platform, and then we have a product that we've built on top of it, which is an enterprise podcasting application for internal podcasts to companies. And this talk is kind of about our journey with that application, and it's really about one of our side quests, to refer back to the great keynote. So when we started building this podcasting product, we weren't entirely sure that people were going to be interested in it or not, so we wanted to build something quickly. We wanted to get it out in the market, see what people thought about it, see if they liked it. Turned out they did. Great. Awesome. So next step is fixing all the code, right? No. The next step is adding more features so they're happier and happier. So we started adding these features, we started handling all these extra cases that, this customer needs this customer needs that, et cetera, and before you knew it, we ended up with legacy code. So I don't know if anybody's read Michael Feather's Working Effectively with Legacy Code, but in that book, I recommend it, he defines legacy code as simply code without tests. So what does that mean? What he's really talking about is it's code that's difficult to change. So you come in, you need to make a change, there's a bug, there's a new feature that needs to be added. You want to change the code, but there's a bunch of things that you don't want to change. There's a bunch of behavior that's important that you want to maintain. And do you feel confident making that change without breaking other stuff? Tests are one way to accomplish that. And that book is really about how to ensure that you've got good tests in a code base so that you can make changes with confidence. As we were rapidly developing all this new functionality, we were starting to feel not confident making changes. We normally have a pretty rigorous TDD process at UStudio. We do a lot of code review, but we were working pretty quickly. We brought some new people on, and we didn't maybe do our normal sort of like, this is how we do TDD, this is how we pair, this is how we do code review, et cetera. And so we ended up with code that was a little bit different than we're used to working with. And so we were starting to find it difficult to maintain. So we started feeling like we had legacy code, but we did have tests. So we redefined it. Legacy code is code without types. We had worked with MyPy before, and we knew that we would get a lot of benefit from type annotations, from a static type checker. And so we thought that this was maybe a good opportunity to start adding type annotations to our code. So the first project we started with was a project that we use for managing users. We've got our application does SSO with our customers, enterprise identity provider. We also have an interface so that they can, on the side, manage users using SCIM, which is an industry standard protocol. And there's all this sort of complexity around, well, the identity provider said this, but SCIM said that, but then the administrator wants to go do this other thing. And so it ends up being sort of complicated. And so we wanted to get it under control, and we knew that what types would help us do is they would help us say, okay, this thing is a request that's coming from SCIM, this thing is a JWT that's coming from the identity provider, et cetera, and it would help us rein it in and make the code easier to understand. Several of us were familiar with this book, and we'd use these processes for adding types, and so we knew that the process described in this book we thought would be helpful to us. So the way the process works is, the first thing you do is what you don't do. You don't go in and just start writing tests. What you do is you say, okay, I've got this feature I need to add, or I've got this bug I need to fix, or a change that I need to make for another reason. My boss is asking me to make this change. A customer is asking me, that's a real change I really need to make. So that's identifying the change points. Then you say, okay, I need to make sure that this code, the important behavior doesn't change. I don't have any tests, so I'm going to write tests. So that's what these steps 2, 3, and 4 are. They are finding places where you can write a test, breaking dependencies up so that the tests are easier to write, and then writing the tests. And all of this, you haven't made your change yet. All you've done is write tests for the existing behavior. And then, once you're done, you can make changes and refactor. So we knew that was a solid model to work with, and we were looking for a way to use that same algorithm, but with types. So our sort of idea was, again, identify the change points, figure out, okay, we need to add this feature, we need to fix this bug, this is the bit of code we need to change, let's type annotate it so that we can describe all the invariants in the type system, and the type checker can help validate them. And then, so we type annotate them, we type check the implementations, meaning we run the type checker on it and it tells us whether something's wrong or not. And then once the type checker says, okay, you're good, everything's good, in addition to the tests saying everything's good, we can make changes, we can refactor, and we'll have this extra layer of confidence that the type checker is helping us out. The problem that we ran into is that when we started digging into this code base, it was very difficult to add type annotations. And the real sort of fundamental problem was that all of these representations, the skim representation, which is the specification, the OIDC representation, which is a different specification, they were just threaded throughout the code. So you'd have a function and it would take a user, and it might be a user from a JWT, it might be a user from a skim request, it might be a user from some other interface, and it was just still in that format. And so the function would accept a user of any type, and then it would do something, it would call another function, and that function would accept a user of any type, and et cetera, et cetera. And so there was not a good solid, like, this is a user, I can add a type annotation to this function that says it's the data class user or the type dict user, and it always has these keys in it. That was not the way the code was written. So unfortunately, we didn't do this. So what we decided to do was sort of tweak it a little bit and rewrite the code. So every manager, what they want to hear, we're going to rewrite the code. So we didn't want to actually go rewrite the whole project. It wasn't necessary. And so what we did was we still followed the same algorithm. We found a piece of code that we needed to change. We figured out what the interface should be. We wrote types to define what the interface should be, define what the operations are supposed to be. We and we ignored the rest of the system. So I'm in this bit of code, I want to add types. I know this function is also useful in this other handler, but I don't need to touch the other handler. We're going to leave that alone. We're not going to change it. We're going to accept the fact that it's not type annotated yet. Maybe someday we'll get back to that. There'll be another feature we need to add, another bug we need to fix over there. We can handle it then. But really, the goal here was to break it down into little chunks and do as small as possible. The other thing is, some of the interfaces were internal to us. They're not public interfaces. And we knew that they didn't really match the requirements very well. So we knew we could change those interfaces. And so we thought that using types to define what the invariants were would help us identify what the interfaces should be. So if we start from the bottom, what are the invariants? What do I need? What do I not need? That helps define the higher level interface in a way that there's fewer corner cases. You don't have to worry. You know you always have the things you need because the interface has forced it. So let's start with talking about how we define types. So the first thing we want to do is define a canonical representation of each resource. We don't want to be passing around, well, maybe this dictionary, it might have, you know, the username might be name, but then this other one it's full name, and this other one it's display name, and this other one it's subject. We just want one thing. So we define the types, and we tend to use data classes. The other rule that we have is, unlike this code up here, we try to avoid using optional. So the thing about optional is it means it can be none. And what that means is everywhere you're doing something and you want to operate on that, you have to check to make sure it's none or not. And that adds a lot of incidental complexity to the code. You need a test for all of those functions, when it's none, when it's not none. You need these if statements. You're trying to read the code. You're trying to figure out, okay, I'm debugging this issue. I'm stepping through the code, trying to figure out what's happening. Oh, is this thing none? I don't remember. Let me go back and look at the handler, and does it get passed in, et cetera, et cetera. So we try to avoid that. Instead, what we do is we break things up. So in this example, let's say you've got a user. A user can belong to groups. Groups are probably stored in a different table. When I'm querying the database, if I don't care about the groups, I probably don't want to waste time doing the join. But sometimes I do care about the groups and I do need the join. One way to do it is with optional. The other way to do it is with two types. So I've got a user, they've got a name, they've got an ID. I've left all that other stuff out. And then I've got a user with groups, and that type says I've got groups and I always have groups. So now my function that does something with groups takes a user with groups, it doesn't take a user, and the type checker will make sure that I'm always passing in a user with groups. Inside that function, I don't have to worry about is group set or not, did I accidentally call the wrong function from the wrong place. The other thing we do is defining operations. So when you're working with a database, you want to insert a new user. There's a bunch of attributes that you need. Every user has to have a name and an email and an ID or whatever the rules are. So that's a user to insert. However, if I'm changing a user, I shouldn't need to give you their name if I want to change their email address. I just want to change their email address. So now, here we do have optionals. And I can say, here's a user to update, and only the things that the user wants to change are in there. And that way, we can disambiguate. You're never going to send in a partial user to the creation function, but you still can send in a partial user to the update function. We actually don't use optional in our user to update. We have a sentry value that tells us that the request isn't trying to change this value, which lets you set it to null if you need to, if it's like a really optional in the database optional value, but just to keep the code shorter. The other thing we did was, you can see I'm using data classes here. That was our other rule, is we really tried hard to use data classes as much as we could. They're nice, they're easy. They are sort of decoupled from whatever libraries you're using for doing input parsing or talking to the database. You really don't have to worry about, oh, well, I'm just going to call this function and it happens to do an update in the database and I forgot about that and I'm in some bit of code that I'm not supposed to be doing that, or I'm outside of a transaction or whatever. Data classes sort of solve that problem. It's just data and nothing else. The one exception to that, which I don't think I have on the slides, is for input parsing, we use Pedantic for input parsing, which is really nice when you're using type annotations because it's got a MyPy plugin, and so it can ensure type safety, but it does not handle data classes very well right now. You end up getting like not that data class, you get like this temporary data class, which makes things difficult. So those are some of the rules we followed, and then this is the process we follow to merge type annotations and test-driven development. So one of the things you'll find if you're trying to do both is two things will start complaining to you. The type checker is complaining to you that you're not handling all the types correctly, and the tests are failing because you haven't implemented the code yet, and it can sometimes be difficult to figure out, well, who do I want to make happy first? And so we sort of came up with a process and refined a process over time. So the first thing that we do is we define the narrowest possible type. So this is akin to the happy path test case. Everything's good, there's no errors, nothing that optional isn't set, it's all good. So we define that. The type checker will be happy, there's no null that we're not checking for or anything like that. So we write the test case for that to just find what we want the function to do when it gets this data that's happy. We make the test pass, normal process. Then we expand the type. So we say, oh, actually, you don't need a name. The name can be optional. So let's go into the data class. Let's make the name optional. Now, MyPy or your type checker of choice is probably complaining to you that you forgot to put an if statement around something. And so now the type checker is telling you, hey, you need to handle this condition. Now you can write a test. Okay, I've got this condition, I want to handle it. What do I want to do? Well, the type checker doesn't make sure it does the right thing, it just makes sure it does something. So you want a test that says the right thing happens. Now you can make the type checker and the test pass and repeat. Do it for the next thing, do it for the next thing. One of the other tricks here is, depending on your editor and depending on how ADD you are, I guess, it can be difficult to run the tests while the type checker is telling you that the code's wrong. In Python, that works. There's no compiler. The type checker can be super unhappy with you, and Python will be perfectly happy to run the tests. But sometimes it's advantageous to make sure that the type checker is happy. So one thing that we do there is sometimes we'll deliberately handle the case incorrectly. So the type checker says, I need to make sure I do something when this is null. I write code that does clearly the wrong thing when it's null. Then I write my test. I run the test will still fail, and I can make sure that it's failing for the right reason. It tells me that the test works correctly, and then I can go fix it. So the type checker is sort of telling you what tests to write as you go along, which is very helpful. So that worked great. We were really happy with the results of that. We were able to resolve a lot of issues. We were able to start adding new features, fixing bugs. We had a lot of confidence that we weren't breaking things anymore. But we had another project. The other project was the API that was sort of the shim between our podcasting application and our platform. When I say the shim, it started as a shim. Slowly over time became a lot more than a shim, and it's got its own database with its own set of data that doesn't fit in the platform. It's got administrative APIs and user APIs, and it's got a bunch of stuff. And so we're running into similar problems there, and we similarly wanted to use MyPy to type check it. In this case, the code was pretty well decoupled, so it was actually a lot easier to gradually add typing. So we started using gradual typing, which is sort of the promise of MyPy. Oh, you can just add some type annotations here and add some here, and we'll sort of help you, and then you can, sort of turn up the volume as you go along and get safer and safer and safer. So that's what we wanted to do. So this was what we ended up doing. So based on the same working effectively with legacy code, we identified change points. Again, we need to change this function, we need to add this feature. The first thing we do is, I'll say, we add the any type annotations. So we add type annotations, and we're trying to get MyPy to be happy, and we are usually running MyPy in a pretty strict mode. So it does allow any, but there's a lot of things that it doesn't allow. It doesn't allow implicit any's, and it doesn't allow a lot of things that Python would let you do. So the first thing we do is we try to do a very minimal pass. Just add the type annotations, make MyPy happy, even if we're unhappy with the code. So we can use the any type, we can use casts, it doesn't really matter. But just get MyPy happy. Now we can go back and start refactoring the code, removing our uses of any, removing our casts, really locking down what the types are, and locking down what the invariants are so that the type checker is actually checking things, and it's not just, well, you gave me an any, so it must work, so sure. And then we stop. So at this point, we've probably got a fair number of code changes. A lot of them are probably pretty rote. They're probably not that complicated, but there's a lot of them. There's a lot of them to sift through, and we don't want to mix them up with the change that we wanted to make. Originally, the feature we wanted to add, the bug we wanted to fix. So now we open a pull request, and we go through the normal code review release cycle. So somebody comes and reviews the code, they make sure the type annotations are correct, they can check that we haven't changed the behavior in a way we didn't expect, and they can understand what the type annotations mean, what we're trying to encode in the type annotations. We merge it, we go to stage in production with it, go through QA, our whole sort of continuous deployment cycle. Then we make the changes that we want to make. And that now, when we make the changes we want to make to the tweet, Kent Beck's tweet, hopefully they're easier because hopefully the types are telling us what we need to do. And then when the person reviews the changes, they're only reviewing the actual change. Oh, I see that you're adding this feature. I see that you're fixing this bug. I don't have all these like weird refactorings that I'm reading through, trying to figure out where's the actual change you wanted to make. Keeps things very simple. So that was the process we went through, and that was working pretty well. So when you're gradually typing, a lot of times it will be very difficult to keep the change from really growing out of control. So like I said, we like to use data classes in our type annotated code, but in our old code, we're basically just using dictionaries. The problem with the difference between the two, we go, oh, let's go change this user, make it a data class, type annotate everything will be great. Actually, let me start here. So you've got a file. You need to call, the layout got messed up, but you need to call, you've got some functions that are related to admins, some functions that are related to viewers, but they're all sort of users and they're all in one file. The feature I'm changing is just for viewers. It has nothing to do with admins. I want to type check this file, but I also don't want to type check this file because I don't want to mess around with the admin stuff. So the first thing I do is I split it up. So I can split the file up. I can take the admin stuff, I can put it in its own place. I can take the viewer stuff, put it in its own. It's probably a good idea to do anyway, but oftentimes we're a little lazy and we don't want to think about, well, is this an admin thing or a viewer thing, or this is where the admin changes the viewer, so which one does it go in? I'll just stick it in the common place. So one of the things that we found is that this really encouraged us to add a lot more fine-grained organization to the project. We could go create a module or a package, called admin, put user in it. We can say, well, we're type annotating admin, so it's the type checker type checks the whole thing. We don't have to remember to maintain the list of these are the files that are in our type checked, etc. And then the other thing we do is we can cheat. So there's two ways we can cheat. One is we sort of break one of our rules. So maybe we want to use a data class. We've got a user. We want to use the data class to represent the user, but I've got a ton of code, and I'm not really interested in changing all of that code. I use a type to dict instead, or I'll use a pedantic model where maybe I would normally not want to use a pedantic model. We're really trying to strike a balance between making sure the type checker is really doing a great job asserting things about how the code behaves, but also not just opening PRs that are like, here's 10,000 lines of code that changed, and all we changed was user sub name turned into user dot name. It's not too hard to review, but it definitely gets tiresome after a while, and so try to avoid that. And then the other thing that we've sometimes done, although would rather not, is we can type annotate functions but not add them to the type checker. So I've got some file in my handler. I want that to be type checked. It's calling some function. The function's in some file that's very complicated and difficult to get the whole file to pass the type checking correctly. I can add type annotations to the function but not have the type checker make sure they're correct, and at least assuming that I got that right, which is an assumption now, the code that's type checked will be correct. So that's it. So we are very happy with the results of type annotating the code. Like I said, we were able to really hone in on some of our interfaces that are internal to us. Obviously, we can't change external interfaces, but being able to say, okay, this type represents the operation I want to perform, really lets us think about what do you need to perform this operation, what do you not need, and it let us design interfaces that were really, they removed a lot of the ambiguity in the requests, so you couldn't make the request, if you made the request to the wrong endpoint, it was obvious in the code that this isn't going to happen, you just get a 400 error or whatever, and not change the database incorrectly or something like that. And we found that when we have to go back and tweak those things, the code that we've touched already, we can make those changes a lot faster because the type checker is helping us tell us when we're making a mistake, tell us what this thing needs, what this thing doesn't need, etc. And Yeah, I think that's it. I also wanted to give a thanks. Tim is here, so if you have any questions about what we're talking about, he's paired with me a lot on this and helped come up with a lot of these processes. So it's very much a team effort. And John, who isn't here, but John did a ton of code review for us, and I wanted to thank him because I know people aren't always great. Code review isn't always the thing you wake up and want to do in the morning, but it's super, super important and very helpful. So I wanted to say thanks there. And I think that's it for me.